differentiate g of x equals 5 to the 1 over x power. This one's going to be a little bit more complicated because it's not just a number raised to the x power. There's a little bit more going on. And I actually want to rewrite this just a little bit differently. This is the same as 5 to the x to the negative first power. The reason I want to write it like this is because it makes things a little bit more clear that we have a composition of functions. So we're going to want to use the chain rule. But then also, this is a power function inside, so we're going to need to use the power rule in there. So let's see how the chain rule works with this. When we're taking the derivative, we need to take the derivative of the outer function. The outer function is 5 to the u power. In this case, the derivative of that is going to be 5 to the u, or 5 to the x to the negative 1, times ln of 5. Remember, when we're taking the derivative of an exponential function where the base is not e, we have to multiply by ln of the base, that constant factor. But then remember, we're using the chain rule, so we have to multiply by the derivative of the inside. The derivative of x to the negative first is negative 1x to the negative second. So let's rearrange things a little bit. This x to the negative second can be written as x squared in the denominator. And then I'm going to take the negative 1 and the ln 5 out front. So negative ln of 5 times 5 to the, and I'm going to rewrite x to the negative 1 as 1 over x just because that's how it started with. And so this is what we get when we take the derivative. A little bit more complicated than just 5 to the x. There's a fair bit more going on, but not that bad if we use the chain rule.